Hi everyone, welcome again. So this is the third video of our Azure IoT end-to-end project series. In the first video we have covered what exactly IoT is in general. In the second video we have tried to cover what exactly customer situation is, right? Because before we wanted to jump to the solution, we needed to understand the customer situation in a lot of detail so that we can look at the bigger picture. In this video, we will be covering the solutioning part. We will be covering and implementing the end-to-end solution into your Azure IoT, Stream Analytics, storage account, Databricks, and a lot of other things. We will be touching a lot of services. But what I would recommend that before you jump to this video, if you haven't covered the last two videos, I'll recommend that please cover these two videos into the Azure IoT end-to-end project playlist, right? So first is your the project overview, the second is your customer situation, right? And now let's jump to the solution, how we gonna be implementing this solution. So what we are planning to do, since we don't have physical devices with us, we don't have smart meters with us, we gonna be simulating this smart meter into a VM. Inside this VM we gonna be installing Visual Studio. Inside this Visual Studio we gonna be simulating and coding a virtual or simulated smart meter which will be sending two information. The first is your temperature, the second is your voltage, right? And then we will be ingesting this particular information into your IoT Hub. So this left hand side portion we will be doing in a VM, right? But before we jump to how we will be simulating it, how that VM looks like, how things works in on field. So let's say you as a manufacturer or you as a power company installed a new device. Let's say device ID is 1000 into a customer premises. How this device, when it powered on, will be communicating to the IoT Hub, right? Because daily we're gonna be installing thousands of devices. We cannot do it manually. We cannot feed the device, we cannot feed the IoT Hub address and all. So for to make this thing streamlined, we have a service called device provisioning service. Now what this device provisioning service is and how it works in production, let's have a look. So it's basically an 8-step process. The first step is manufacturer will create an enrollment list into device provisioning service. So basically in simple term, let's say we have a new device with ID 1000. The manufacturer or the company will make sure that it will be added to the list. The second step, what it will do, it will pre-feed the device with the device provisioning service address. So let's say there is an API address, something called HTTP 10.10.80. whatever. So what device manufacturer will do, it will pre-feed the device with the same address. So two steps done. Now once the device is turned on, what it will do, it will pass its device ID to the API of device provisioning service, and device provisioning service will match the ID 1000 to its enrollment list. And now if the ID matches, it means the device has been authenticated. So what in more theoretical way, DPS, device provisioning service, validates the identity of the device by validating the registration ID and the key against the enrollment list entry using a nonce challenge, or it can use standards like X509. Once this is validated, what DPS will do, DPS will register the device with our IoT Hub. So this is the fourth step. So DPS, Device Provisioning Service, will register the device with the IoT Hub, and now IoT Hub will create a digital twin of this device into IoT, right? So basically now device has been registered in DPS. DPS has connected to the IoT Hub, that okay, we have this device, and IoT Hub has created a digital twin, right? So 4 steps done. And the fifth step is, now IoT Hub return the device ID. Which device ID? Digital twin device ID to DPS again. This is the fifth step, right? So 5 steps done. Sixth step is DPS returns the IoT Hub connection information to the device, and device can now start sending data. So DPS has IoT Hub information. IoT Hub has created the digital twin information, and it says okay, the digital twin has been created. Now sixth step is, this DPS will send the IoT Hub information to the device, and now device can send data directly to IoT Hub. Device provisioning services work done, right? So basically 7th step, device connect to the IoT Hub, and device get the desired state from the digital twin or device twin from the IoT Hub. So let's make it simple again. First, manufacturer will make sure that it in the enrollment list new device ID is listed, and it will make sure that in the device DPS API ID is there. Now when device is powered on, it will send its ID to the DPS service. DPS will validate it. If it is validated, it will connect to IoT Hub, send the device ID to the IoT Hub. IoT Hub will create a digital twin state and send the information back to DPS service. Now DPS service will send this information of IoT Hub to the device as a 6th step. The device will connect directly to the IoT Hub now and will start sending data. So this is how device provisioning work. So this is your device to cloud communication, right? D2C communication. Now let's say we want to send some signal back to device, cloud to device. How it will work, right? So basically it's again simple mechanism. So this is your device, this is your service which wants to communicate to the device. So now to communicate with the device, it cannot send signal directly to the device. Why? Because device has no feature to validate it. So basically to communicate with device, it needs to send information to Azure IoT Hub. It needs to validate itself. Same thing device needs to do. If both the pathways are validated, then the information can be flowed from services or external providers to the device through this. So basically on a very simple term, Azure IoT Hub will act as a communication channel from device to cloud and to cloud to device both. There are other details as well, but this is the most simplest form, right? So this is how your communication work. One more thing which we need to cover is, most of the communication, in fact all of the communications, will be done using all these protocols. Either it will be HTTP post, AMQP, MQTT. So these three are the most important protocol when we talk about IoT Hub communication, either from cloud to device or device to cloud. Okay, so the first thing what we need to do is to create a VM which will simulate the smart meter. To do it, we will do one thing. We will go here in Azure portal, we'll create a resource group, right? So resource group is nothing but a container for this particular project, right? And let's say we will create a resource group called IoT and IoT project, right? We will be creating this resource group, let's say in Europe, North Europe, and we will say review and create, and we'll create it. So once this resource group is created, we will be going to this resource group, and we will be creating a VM, and this VM should be installed with your Visual Studio. So we will directly search for Visual Studio. We can do it in on local machine as well, but I would prefer to go with this Visual Studio 2019, right? And we can go for 2019. Let's see this one. And let's select this one. Let's go for create, and once this is done, we will be naming this machine actually demo machine. I have already done it, but I'm just showing it to you guys. Demo machine, let it be pre-populated, let it be same. We will go for, let's say, demo user, right? And we will put some password here. So please do remember this password, and then we will create it. So I have already done it, so I won't be creating it. So once this is done, connect to this machine, and inside this machine, what we will be doing, we will be creating this project. So don't worry if this doesn't make sense to you. I will be putting this code into my GitHub, and from there you can have a look into it. So basically, in this project, so this is how your end result will look like. So what we have done, we have simulated 9 smart meters. These smart meters will be sending we'll be sending temperature, device ID, and the timestamp. And it's not scrolling, but there is uh, um, virtual voltage as well here, right? So let's not jump to the code because this is not important, but this is how basically what you need to do. You need to import a project, right? Or when you go here, so just download it, and there will be a solution file. Double click it and it will open it. So I don't want to focus on it, but once you double click it, this page will open, and we gonna be covering what we need to do with this page, right? So once this machine is created, open your RDP, right? Open your RDP, connect to this machine with this IP address. Now, once everything is done, go to that machine. That's I have already done it, and I have already created the machine and everything. The first thing what we need to do, we need to create or download the code of the simulator. So I have downloaded this code, I have modified this code, and what I will be doing after this video, I will be sharing this code using the GitHub to you guys. So link will be in the description. So once you download this code, you need to double click this smart meter simulated solution file, and it will open that file into your what we call into your Visual Studio, right? And this is how your smart meter look and feel will be. So what we will be doing, we are simulating 9 smart meters, right? And these smart meters will be generating 3 things. every second, device ID, temperature, and timestamp. And we will be needing two things. One is your DPS group enrollment key and DPS ID scope. Don't worry if you don't understand this right now. Don't worry again about the code and all. The only purpose of this particular VM is to act as your smart meter, simulated smart meter, right? If you have any doubt, if you are not able to upload it, not able to open it, do contact me in the comment section. But for me it worked like a charm, so for you also it should work in the first go. Okay, so this is your smart meter simulator looks like. We won't be doing anything right now, but this will be used in later section, right? So this is your smart meter simulator in simple terms. Second thing, what we will be doing, we will be creating our Azure Databricks. So let's say we will call here Databricks, and this Databricks will be used to analyze and process the data, right? So we're gonna be creating your Azure Databricks here, and in this, let's say we'll call it IoT Databricks, let's say, right? And we're gonna be doing it into Europe again, North Europe. Pricing tier, we will be doing it into standard, and we'll go for the networking, deploy Azure Databricks with secure cluster connectivity, deploy Azure with your own virtual network. I think let it be default. We enable infrastructure encryption. We are testing it, so we don't need it. Let's go for tag. The tags are more for billing purpose, how much this particular service costs. It's always a good practice. IoT project. So let's say IoT project, and the values, let's say IoT, simple. And we'll say review and create. So if it is validated, we can create it. So it will be created in some time, and once it is created, we will be moving up to the next steps. Till the time your Databricks is created, let's create a few other services. IoT Hub, right? So this is your IoT Hub, and we will create IoT Hub, and what we will be doing, we will be creating this IoT Hub into your IoT Hub project, right? And we will give it a name. What should be the name? Let's say we can give it a name as any name. Let's say IoT, sorry, test IoT Hub, simple, right? And not available, so let's say 101. It's available, and we'll again create it into North Europe, and we will go for networking, public access, let it be there. We'll go for management. Okay, which pricing tier we gonna be doing it? We will be doing it into S1 standard only, right? Because we are only practicing it. And now next thing is how many IoT Hub unit we need to provision. So let it be one. We are not changing it. So yeah, this is important. So basically pricing and scale tier S1, it will, so these are the things what we need to know. It will send device to cloud messages, that can be done. Messages, how many messages can be sent per day? 400k. Cost per month will be 21.08 euros. IoT for Defender for IoT is there. Everything is like, you can read it. Now the next thing is We can go for shared access signature, shared access policy. It's good. Partitions should, like, what are partitions? The number of partition relates to the device to cloud messages, to the number of simultaneous reader of these messages. So basically what it is saying, how many parallel process can read data at the same time from IoT when devices are sending data. So let's say we want to go for 4. We want to go for add-on. Do we need Defender for IoT? I think for testing, let's not do it. Go for tags, go for IoT again, and let's say IoT only. Okay, and review and create. So this will create your IoT hub. The second thing is what we need to do. So it will take some time. Next thing is your okay, so let's wait for it first, and then once it is done, so see, it start with your test IoT hub. It will create other services. So now, since we have our this created, Databricks created, let's go to our Databricks workspace and sign into the account, and let me create the cluster first, right? So let it get signed in, and we will create a cluster as well. So these things will take time, like just to set up. So we'll go for compute here. We will go for create cluster. I'm single user, and so we either go for single user or isolation, no isolation shared. I think the default one is okay for us. What we need Scala 2.12, latest version of Spark. How many nodes we need? So I think this is fine. Minimum workers or max worker, I can put it 5 for now. Driver type, same as worker. Tags, I think no need for the tags here, and let's go for create the cluster. It will take some time. Once the cluster is created, we will move to the next. Okay, so when we see here, our test IoT hub has been deployed successfully. Let's go to the resource. So our cluster is in progress, so let it be created. So what we need to see here, so see, this is created in resource group IoT project. The status is active, testing pair is good. One thing, the most important thing is your scope, idea and scope. So let's see. So here should be ID and scope. Refresh it. IoT Hub and DPS are updating their TLS certificate. I think that's okay. Refresh it. Okay, so the thing which I'm looking for will be in device provisioning service. So I was looking for a scope, so it should be in device provisioning service, which we can create later. Since the IoT Hub is created here, we'll go to your shared access policy. In the shared access policy, what we need to do, we need to select this, right? And we need to copy the connection string primary key field. Okay, so we'll select this, and we need to copy this part, primary key, right? I'll just copy it and I'll copy to it to the notepad, or in fact to our OneNote, let's say. So I'll create a new notebook, I'll copy it, sorry, Control Z, and I'll copy paste here, right? So this we can use later. So in the IoT Hub, what we did, we copied the connection string primary key and we recorded it, right? And now what we are seeing here, that this particular IoT Hub owner can read, write, connect to the service, connect to the device and everything. So this is good. So we have copied it. So primary key, what we have here, we have primary key, we have secondary key, and we have primary connection string. So we need this part. So I'll paste it here. So we have your shared access key and everything. Okay, so these are sensitive information, don't share it with anyone. Right now I'm sharing because I'm gonna be deleting everything once this video is done, right? We will be canceling it. So this is done. So now what the next step we will be doing, we will be looking for device provisioning. So this one, Azure IoT Hub device provisioning service. We gonna be creating Azure IoT Hub device provisioning service, and selected subscription, selected the project name. What name we can give? Let's say we can give here smart meter DPS, right? And again, try to keep everything in the same region. So let's say North Europe, and go for your networking. Everything is great. Management, it will give us the S1 standard. 1000 operations will cost you $0.169. That's okay. I'll go for tag again. Not needed, but ideal, right? Review and create. So it will create some device provisioning service. Once it is created, it will take some time. Now meanwhile, let's go to your Azure Databricks cluster. What we can see, that your Databricks cluster is up and running, and we have your cluster compute node ready. So yeah, so now the cluster name is Nilen Singh cluster because it's me. I haven't changed the name. Runtime is 10.4, active memory 12 cores, active dbu per hour, everything is cool. We will be using it in some time. So if you guys want, you guys can pause it and terminate it. One thing which I need to see here is whether it will stop. Oh yeah, so this thing, I will say edit. Do one thing, auto scaling, if you guys want, that's okay, but just to save cost, make it 30 minutes, even 15 minutes. Okay, so confirm and restart. So this is cool, it will restart and change thing. So now device provisioning service is done. Now what we need to do here, the most important thing is your idea scope. This one we will copy it, and why I'm doing it, I'll tell you later, but just do what I'm doing right now. So this is important. So you copied it, and the second thing is, do one more thing here, linked IoT devices. In this DPS service, go to this particular linked IoT hubs, right? And in this linked IoT hub, do one thing, add a device, right? And add our IoT hub. So this is our IoT hub, since we have created in the same resource group and all. So this is your IoT hub, right? So till now we are good. Location, everything is great, and we will say save. So it means that our IoT Hub has been registered with your DPS service. So now once the IoT device will communicate with DPS, and if it's validated, it will make sure that this IoT Hub has been properly informed. DPS can inform it, right? Now, next thing what we're gonna be doing here is manage the enrollments, right? So now what we need to do, we need to create enrollment groups, or we can create individual enrollment. So you remember when I was telling you that device manufacturer needs to create enrollment group or individual enrollment. So we'll go for enrollment group creation, right? And in this group creation, we need to add a few things. So let's say we will call it smart meter device group, right? This is okay. And so basically, what is the attestation type? So how your device provisioning services will authenticate. So basically, select whether we are going to be using symmetric authentication key or X509. So let's say we are going for symmetric key, right? And what it is, auto generate is checked. IoT, so we are not putting anything here. And how you want to assign devices to hubs, let's say evenly distributed. And select the IoT hub this group has been assigned to, it's already there. We don't want to tag it, and this is good. And we will be enable the entry, yes, and save it. So what we have done so far, okay, I'll come to it later. So this is done, right? So now when we go here to the overview and go to resource, what we have done, we have registered our IoT hub, we have created the enrollment group, and now the last thing what we need to do here is when we go here into the manage enrollment and this one, and so we have your primary key here. So now we need this primary key as well, right? So what we will do here, we'll paste it here. So this is here, let's say DPS PK, just to make sure that you remember it, right? So we have copied it as well. Now, so let me recap what we have done so far in terms of what I have started with from the device provisioning point of view, right? So let's forget this all part for 2 minutes, and I will tell you what we have done in terms of this particular diagram, right? And then you yourself can see what else needs to be done, right? So we have created IoT hub, right? We have created a device provisioning service, we have created the enrollment list, we have registered this IoT hub with the device provisioning service, right? So this side part is done. We have kind of not 100% created our VM for the simulated device. Now what we need to do, we need to make sure as a manufacturer of this device into our simulated environment that our device should have the information of this device provisioning service. This is what we need to do, right? So what we have done so far in this section, we have all the details. We have the scope of our DPS, we have our DPS primary key, even we have the access key for our IoT hub. So we have everything. So now when I go here to my VM. What is saying? You have got an update. I don't want the update. We need to do one thing. We need to update here. Main form design here. So once you click it, you need to update your, so let me copy this particular key, DPS enrollment group key, here into the text section and paste it here, and this particular scope ID, copy it and paste it here. So what it means in very simple terms, as a device manufacturer, we are pre-feeding our device with the IoT hub or the device provisioning service address. Simple, right? So now when we go to this diagram, we have pre-feed this particular section with device provisioning service address and all. So now once we start the device will send its ID to here, and validation and everything will take care. So kind of we have covered the whole infrastructure, right? So now this is great. So what else we need now? We need to start the device now, right? So let's go here and let's say we want to start the simulator. Let's see if it works. So it will start the program. So see, now what it will do, it will bring up a window. If this program runs okay, it will compile it. Okay, fantastic. So it means our program has no error. It is ready to run. Now what we need to do, we need to register the device first, right? So if this windows comes up for you guys, it means your simulated environment is ready to run, right? So this is okay. You have put your DPS enrollment key, you have put your DPS ID scope, and now what you need to do, you need to click one of the device. Once you click it, it will turn yellow, and now once you so it means it is ready to be registered, right? So let's go here once and let's see from where we are reached till here. So we have clicked power on the device, and let's see how the data will flow. Okay, so what we have done, again why I'm covering this, so that we are on the same page. So we have clicked the device, it means we have turned the power on. So yellow means we have turned the power on. Now once we click register, so let's say we want to register 2 devices, so we can go here, click 2. So it means we need to register 2 new smart meters into customer premises, and we will say register. So if the registration is successful, the color will change to blue. So it means this device has changed its color to blue. It means the registration is successful. What it means? It means this device has been registered successfully to your IoT. So now let me go back to the provisioning. So this device has sent the information to the enrollment list validated, and what we will be seeing that IoT Hub should have, and I'm not sure, should have the digital twin copy of this particular device, right? So let's see. So now when we go here, we go to your IoT project, and let's go to your IoT Hub. In IoT Hub, let's go to devices. Fantastic. See, we have created the device. Now device 0 and 1 has been registered here. the status is enabled, authentication is through the shared account key what we have put there, and we are good to go. Right, now let's do one thing. uh, let's go to your DPS, let's go to your manage enrollment, let's go to the device group, and let's go to your registration records. Wow, fantastic. It means device 0 and device 1 came to your DPS service and registered at this particular date. So what we have covered in theory has been successfully implemented into your Azure IoT Hub DPS portal. Till now we are good, right? Now let's go here. And one more thing I'm emphasizing, if you are not getting it, that okay, what exactly this is doing, so don't worry, we can cover the code later. So what else? Okay, so till now we have covered the device registration and all. Now let's see, once so registration is done, so means your uh, VMs or smart meters in the VM uh, are registered properly with your IoT Hub, right? Now let's see if we want to send data to IoT Hub. Let's see. Now let's say when we say connect. So connect means it will start emitting data. Okay. So see, device 0, device 1 are sending data every second. Okay. And the color will change, blue, red or green based on the temperature. And don't worry, this is again fancy thing. So if the temperature of the device is less than 60, less than 68, it will be green, and 68 to 70 blue, more than 72 is red. Okay, so till now the temperature is okay, right? um, or I have changed something, so don't worry, but yeah, start emulating the data. So now the next thing is, um, we need to ingest this data. We need to ingest this data, or we need to process this data, right? So what we will be doing, we gonna be creating our stream analytics job, right? And let's create a stream analytics job, and we gonna be creating it in subscription MSDN and IoT project, and let's say we name it test stream analytics job, right? Which North Europe again, and we will be doing it on cloud. And see, edge means if you want to compute on the device itself, we don't want to do it, right? We think streaming units should be one, okay for now, because we are just testing it. Now go to your storage. Do we need to storage secure account? No, let it be this testing environment. Again, IoT. So it means once we say review and create, let's run the final validation. And once this is done, we will be writing our stream analytics job to ingest data um, to your from your IoT Hub. It will take some time. So once it is created, we will be coming back again. Okay, so your stream analytics workspace or job has been created. Any stream analytics job, you will have four things: inputs, from where the data is coming; outputs, where you need to send this data; and query, how you need to get data from input and send it to output, any transformation you need to do. Functions means if you need to write your own user defined function to process this data, and you need to use those function and query. So let's go for input first. let's create input stream from where we are getting the data from IoT Hub. That's cool. And let's say we are giving it name as, let's say, temperature, temps. What we need? We are needing temperature, right? And okay, that's cool. Consumer group, let's say we default, so we are getting data from Azure IoT Hub. Um, Shared access signature is okay. Testing point is okay. Uh, we need it in JSON format. UTF-8 is okay, and we'll say okay, save it. So it means our input is created, and now what we need to do? We need to create outputs, right? Now, where we need to send this data to. So let's say we need to send this data to Power BI. Okay, and so in the Power BI section, now we need to do one thing here. So basically, this particular user, the user which is creating all these resources, should be creating the Power BI workspace from the same user. Okay, so see, user is not licensed for Power BI. So what we need to do, we need to create, okay, now make it simple. So we'll go home, right? We'll go for Azure Active Directory, and again, see, this thing is not done in this way in production. We are making something just to make things work. For Power BI, we need to do this stuff in this way, right? We'll go for users, and I have created existing user, but let me create a new one. So we'll say create a new user, and we'll say IoT new user, okay? And let's say his name is IoT user, okay? And everything's cool, and let's say created. So this user, once this user is created, IoT new user, refresh it, it should be appearing here. Yeah, this is here now, right? So the user is this. Once I go here, IoT user, okay, now I need to copy this, right? And I will do one thing. I will open a new incognito window, and let's say I'll go for app.powerbi.com, and I'll enter this. I'll say submit, and once new user, and let's say again IoT new user, and copy paste this here again, and let me create the password. So I'll say any password, right? So I'll create my password so that I need to remember it now, and refresh this page. So once we have seen the fifth user, so fifth user is here, copy here, and go back, copy here, submit, and I'll say here my password, sign in, and it will ask me to change the password. And why I'm doing it, and if you guys are getting confused, let me explain it in whiteboard. So basically what we have done so far, we have created a resource group. We have created in this resource group IoT Hub, TPS, blah blah blah, a number of services, right? And now what we want to do from a stream analytics job, we need to read data from this IoT and we need to send data to your Power BI, right? But the condition is that if this Power BI user and this stream analytics or test IoT Hub user is same, then only the workspace from Power BI can be used in stream analytics as output, right? So into our companies, into production environment, we do have the Power BI user there, right? who uh, who is into the same Azure Active Directory. But for me, since I'm using test account, I don't have the same user for Power BI and for the Stream Analytics. For Stream Analytics, I'm using my uh, email ID, my personal email ID, right? And for Power BI, this particular email ID is not registered with the Power BI, because Power BI you need to use your company email address or something, right? So what I've done, I have created a new Azure Active Directory user, and I will be signing up for Power BI using this user. I will be assigning this user as a owner to this resource group, so that all the resources what we have created in this resource group, this user can access. And now I will log in to my Azure portal through this user, so that we can use this Power BI workspace here. Seems complicated, but it's very simple. Okay, so what it's saying for second factor authentication, I don't need it right now. I'll say yes. Okay, it will take some time. And now I'll say accept here, continue, and I'll give for island, I'll say 1 2 3 4 5 6 7 8 9. Right, I understand, and get started. Get started. So now my Power BI account will be creating in, let's say, a couple of minutes. And then what I will be doing, I will be creating a workspace. And so meanwhile, what is doing? Let me do one thing. I'll go to my this one. I'll go to the resource group, this IoT project. I'll go to access control, right? And I'll add a resource role assignment, and I want to make owner of this particular resource group. And whom do I need to make owner? My Azure IoT new user. Select, review and assign, so it means my role has been added there, right? So let's do one thing. Let's test one thing. If I go to portal.azure.com, and if I want to use this Azure IoT user here, and okay, so now it is asking me your phone download. Now I have already downloaded it, so let's do one thing. Next. So it is asking me to using my Azure Authenticator app. Scan this code, right? So I'm scanning it. So it's work in school account, you need to scan the code. So I have authenticated it from my this one, and I'll say next, and I'm approving it on my mobile. So it has been approved, see, and I'll go next. I'll say done, and it bring me to the Azure portal. I don't want to go to here. I'll go to resource groups, and cool. See, I'm seeing the Azure IoT project here. I will go here. Meanwhile, let me try one more thing. I'll go here. Got it. Workspaces, create a workspace. It won't allow me. It will ask me to buy a Power BI Pro license. I'll go for try free, and I'll go for 2, 3, 4, 5, 6, 7, 8, 9, and I'll say start my free trial. Okay, so it will give me free trial for 60 days. That's cool. And now what I'm doing here, I'll go to workspace, I'll create a workspace, and I'll say test IoT workspace. Save. Okay, so we have created a workspace. So this is our test IoT workspace. Now what we need to do, we need to go to our Azure portal. We need to go to your test job. So now when we go here, we have our inputs created already, right? So this is great. Let it get refresh, and so we have inputted created already. Now go to output, go for here, go for Power BI, and now let's say we go for Power BI. See, now this is what I was talking about. So test IoT workspace has been populated automatically. Why? Because this Power BI user, where is that? This one, Azure IoT new user, and this Azure portal user is using exactly same address, user ID. Now this is cool. We have gone here, and let's say we need to give the dataset name, anything we can give. Let's say we can go for average temps, and table name we can paste it here, again the same thing. This is great, and let's try to authorize. Okay, so now it is asking me to authorize. So Azure, what I'll do here, IoT new user, or if I don't want to go here, I'll go for AAAD. Let me try one thing. I'll go simply say save. Okay. Failed, required fresh token. Okay, so user token, let it be user token, and I'll authorize it. Okay, and I'll go for users. I'm just copying the user ID here. IoT new user, I'll copy it here. I'll go here, I'll go for authorize. I'll paste that here. Next, and put the new password what I have created. Yes. Authorization done. Save it. Wow, that's great. So now we are cool. What we are doing here, data is generated regularly every 1 second, but we are not capturing the data anywhere, right? So now what we will be doing, we will be reading the data from input. We have created the output. Now we will be writing a query here, right? So now see, this is the cool stuff. Since there is only one input, one output, it wrote the query for us automatically. And the cool part is that the data coming automatically here. See, isn't it great? We obviously we have done a lot of things, but most of the coding has been done automatically for us. Now since it's simple, what we call SQL query. Now let's say we want to have the average temperature, temp. From where this temp is coming, this temp is coming from here. See, so device ID, temperature, and timestamp. Device ID, timestamp, and temperature. And one more thing which is not getting showed there is voltage. We don't want to use the voltage now, but And since we have given the three partitions and it is showing us which partition it is going into on the IoT Hub side, forget about these things, but let's go for temperature. And as what we need as average, right? And we want ID as well. And from this, what we need to do? We need to group by, group by, and let's say we want to use the tumbling window. If you don't know the tumbling window, I have already covered it in Spark tumbling window sessions, so look for it. We want to tumble every 5 minutes, okay, and ID. Now let's test this query. Fantastic. Okay, so it means, in fact, let me make it 1 minute. I don't want it everyone. Let me test this query. So every 1 minute, it will push the result to us, right? Now, once we save this query, so the setting has been saved. Now, let's go here in the overview, right? And let's start the job. So we have tested the query. We have made the input, output, tested the query. Now we are starting the job. So now once the job is started, we will see some output. Let's see. It will take maybe a minute or so. So one thing which I missed, so when we go back to the overview window, we haven't pressed the refresh button. So once we press the start here, it will give us the start job blade, and it will give us when we want to start the job, whether now or we can go for any custom time, right? So we want to start it now. So let's say start. So once it is done, it will start jobs in, let's say, 1 minute. Okay, so once this job will start, we will go to our Power BI and we will see whether our data set, that is average temperature data set and average temperature table, is created. Okay, so till the time our job is starting, we will do one thing. We'll go to a resource group. We will go to the resource group and let's create one storage account, right? So we'll go here and let's say storage. So you know why we're doing it, right? So storage account, and we will go for simple storage account here, Azure service, and we will go for create. And that's cool. Till now we are good here. And let's say storage account test IoT, simple. And where will we create? Everywhere we are using North Europe, so we're gonna be using here North Europe. Yes, here we're gonna be using standard performance. We want local redundancy. We don't want to increase the cost, right? We will go for next advanced. Do we need REST API? No, we don't need it. Allow public access is okay. Everything is okay. This is cool. And we'll go for access tier is okay. Anything else? We'll go this as well. So okay. So in fact, do we need it? Let it be. And networking, everything's great. Data protection is okay. Encryption is okay. And next tags, if you want to go for IoT, and we can go for IoT. Review. So what we are doing, we're gonna be storing. We are sending results to Power BI through hot stream, and through the cold stream, we will be using this one to store result, right? So this will be creating. Now let's do one thing. Till the time this is created, let's go back to our test job and refresh it. So see, it is in running state, and do we see anything coming yet? So it will take some time. Still not coming here, no ways. So our storage account has been created. So let's go to resource and let's go to your access keys and copy this key. Which one? This one. Copy it. For a time being, paste it here. We'll use it, okay? And okay, sorry. Copy it. Paste it. Why it's not getting pasted? Just give me a second. So this is cool. So might be some pasting error there. Now let's do one thing. Let's go back again, and let's see if it is starting coming. Anyways, let's do one thing. Let's go to our test workspace. See, this is what, even though that's not getting refreshed, don't worry, right? We are not seeing anything running here, anything refreshed here. Might be there's some latency, but when we go to our Azure Power BI, we can see that okay, our Azure data set has been average times data set has been created, right? So now let's do one thing. Now what we need to do, using this particular data set, we need to create some visualization. Now let's do it. So when we go here, what we need to do, we need to say create report, right? And let's say got it. What we need to do, we need to go for your bar chart. Let's maximize it a bit. We don't want the tour, cancel it. And when we go here in this average temperature, what we have average temperature and ID. So sorry, in the access field we have ID. In the value field, so see, this is important. In the access sorry, this one x-axis, right? ID we have here. In the y-axis we should have average. Okay, and this is great. Till now we are good. So this is filters. We don't need any filters now. And in the value field, where is the value? Okay, so this is good, right? So we have device 0 and device 1 here. Now let's do one thing. Let's see if this data is real or not. So let's do one thing first. Let's save this. Let's say average temp report, simple, and save it. Okay, so this is good. Now let's do one thing. Let's go here, register 3 more devices. Okay, and once they are registered, once they change their color, we will connect them. Let's wait for 1 second. And did we press register? Yes, we did. Let them change color, and then we will connect them, and then we will see whether that dashboard is sending results from here and refreshing at the real time. Okay, and meanwhile let's do one thing. Now let me refresh it again. Okay, now that's great. So we are seeing the resource utilization, right? It's 20%. Some data is coming. We are seeing that, okay, 600 messages already came. CPU utilization is 3.5. So it took some time, but it eventually refreshed, right? Not sure why it's not working. Let's do one thing. Let's refresh it. Start the simulator again. So if it is not working like this, because obviously it is taking resources, generating a lot of data. So stop that, start the simulator again, and let's this time we will register 5 devices. Okay, and so this is a trick. If you see that the color is not getting changed, stop it and restart the simulator again, and once all the colors have been changed, then go for connect. Okay, so now this is good. Now let's try to validate first thing first, whether the it has been registered successfully into your test IoT devices. Okay, this is good. So it means all the devices have been registered successfully. And let's refresh this report as well. Okay, so it will take some time, maybe a minute or so, but eventually this will get refreshed. Now let's do one more thing. Meanwhile, we have our storage account created, right? We have our storage account created, and now let's do one more thing. Let's go for Stream Analytics job. Create one more job. In this job, let's call this job resource group IoT project only. Name should be, let's say, cold cold storage, anything. North Europe. Cloud is okay. Streaming unit, I don't need 3, I only need 1. Review and create. This thing is cool till here, and create it. It won't take much time, and meanwhile let me go here and refresh the visuals. Oh, fantastic. So it means we haven't done anything. Since this is your real-time dashboard, everything has been generated automatically, and average temperature for each device has been shown here. That's great. Till now, what we have been thinking is working, right? Now let's do one thing. Go to resource, the new cold storage job. Go for input. Can you guess which is the streaming input? It should be IoT Hub, right? And what we call it, IoT Hub, right? Everything is great. We don't need to change anything, so it means it's good. Now what should be the output? What should be the output here? The output should be your blob storage or ADLS Gen 2, and let's call it anything. Let's say blobs, right? MSDN is okay. Storage account, see what we have created, it's already here, since we are in the same resource group and all. And okay, so this one, create new container, and create this is, let's say, smart meter data. So what it will do, it will create a new container, and this is great line. And let's say if we want to have a path pattern, right? So what we'll say, in this smart meters data, create paths like this. So it means for every date and time, select different folders. Everything looks okay here, and let's say, what's this? Minimum rows per batch. We want to process 100 rows minimum, and maximum time, let's say, enter 3 minutes. Okay, so let's validate. So we have your smart meters created, path patterns created, everything is gone. Let's save it. And now let's go for query. Okay, let's go for output once more. Let's do one thing. The data is coming in not in this format. It is okay, so this is okay, right? And now, so once this is started, it will take another 1 or 2 minutes, and so let's wait for it. Let's go for containers. Wow, so see, we haven't created any containers, right? um, Now let's go to this. Into this container we have a folder smart meter data. In this we have the date, we have month, everything, time. So in the smart meter data container we have the data for 8th of October 2022 for 20th hour. So the structure of the folder has automatically created. Now let's see this data. In fact, let me download it. Scanning. Okay, so let's open with Excel. So what I'm trying to show you here, that every 3 minutes it will be sending us the record, device 0 and temperature and everything. So this is done. This is cool. Now what else do we need to do? We need to do few more things here. Just give me a second here. So what we have done so far, let's go to our project overview document again. So we have covered this part, we have covered this part. Now let's cover the Databricks part, right? So now we have already created a Databricks cluster in the beginning, right? So now let's go here. So our documents are already created into our containers. Go to our IoT project resource group, go to this one and launch a workspace. So it will log in. Cluster is already created. I don't want it. So let me see the compute. Very strange. I have already created a cluster here. Let me refresh it. The cluster is already here. Okay, anyways, let me confirm it. So basically, you remember we have set the setting that okay, cluster needs to be um, uh, stopped if it is inactive for 15 minutes, and that's why it was inactive, right? So let's wait for maybe 1 or 2 minutes and it will be up, and then we will be creating a new notebook. Let's say we call it smart meter analysis, right? let's say the diagram is default language is Python. We're gonna be using this cluster once it is up, and we will be creating a notebook. Fantastic. What's that? Yeah, we will be using this visualization as well. Um, Now, in this notebook, what we need to do, we need to read the data from the storage account, and we need to do some processing, right? So first thing, what we will be doing, uh, we need to create a widgets. So let me show you how it works. So once we copy it and paste it here, and connecting. Okay, so basically it will take a time. It will take some time. It will take a minute or so. Once it is created, we will come again. Okay, so the cluster is up. So what we are doing first thing is to create widgets, two widgets, one for account name and one for account key. So what exactly widgets are, that once we run this cell, there will be two text boxes created here with the name account name and account key, and they are the placeholder. They will be the placeholder uh, for account key and account name. Okay, so let's see now. So once we have done it, we have created your account key and account name here, right? And now into this account key and account name, we need to you remember, uh, we have copied our account key here somewhere. Let me see where it is. Here, so this is our account key. You remember, we have copied it, right? And we will copy this account key here. And what's the account name? Account name is, what is the account name? So let's go quickly into your home, IoT projects, and sales IoT, is it? Yeah, so this is the storage account. So we'll put it here. So it means, so what we have done, once we run the next cells, and we use somewhere this variable, the variable will read the data from here, right? So now the next thing is how to read this data. How to read this data is we need to create a new cell, So let's create a new cell. Let's go to our OneNote and let's read the cells. So to create the cell, you will be using dbutils.widgets.text or drop down, whatever you want to create, the name of the variable and the name of the text box. So this is how you need to create it. How to read it? Variable dbutils.widgets.get, and then the placeholder or the variable name of the widget, right? So now let's run it. So this is cool. And now what we need to do, we need to read data. We need to mount our smart meter data file here, right? So what we are doing, mount the blob storage at mount smart meters. This assumes your container name is smart meters, and you have a folder named smart meters within the container as specified, right? So when we go here, we are going to containers. So our container name is smart meter data, and inside this smart meter data we have a folder name smart meter data. So now what we are doing here, we are putting smart meter data, smart meter data, smart meters data, and smart meters data. So now let's try to run it. Let's see. So if it is runs okay, then it means we have mounted our smart meter data container to the Databricks, and the mount location is mount smart meter data. Let's run it. The next thing is we will be validating whether the mount is successful or not. So the mount is successful. Let's run here, and data runs there. Okay, so what is this? Smart meters data does not exist. So might be the spelling mistake was there, so we just copied pasted it, right? So it's running the command, and let's see. Oh yeah, fantastic. So what we can see, that the data, the containers have been mounted. We can see the folder name, and everything is cool. Now what we will be doing, we will be creating a data frame. Let's see what we are doing. We are creating a data frame for all the files in the blob storage, and it means it doesn't matter how deep the folder structure is, we will be reading everything from the leaf folder, you can see. So what we are doing here, that smart meter data from your Databricks file storage, mount smart meter data, star means go 3 level deep and read all the CSV file folder, CSV files where header is equal to true, and then print the types. When I go here, I just corrected it, that instead of 3 I put 4 stars here. Once we run here, what we are seeing, that it has inferred the schema for ID, timestamp, and everything. So till now we are good. Now when we go here, and once we go for, let's say we want to see the data, right? So once we go here and we'll say df.show, it will show us the 10 rows, right? So it means the data has been, so we have mounted the disk, our container, and we are able to see the data. Now let's do one more thing. Save this data into a table, into a DB database table called smart meters, right? And once we go here, so it will create a table, and then we'll go to the data. So it's, yeah, this is created. Now once we go to the data, we can see a smart meters table has been created into the default database. So till now we are good, but this is not I wanted to show you. Now we will be running SQL using, so first of all, since we are in the Python notebook, if you want to run SQL, first command should be your %SQL. This is called magic command, and now this particular cell of this notebook will run as a SQL notebook. See, this is turned to SQL here, right? So now what we are doing, we are selecting the count and the average of each temperature by the device ID, right? So this is cool. Till now we are doing great. Next thing is we will query the data frame, and we'll see how to do it using your data frame SQL, right? So what we are doing here, that if we want to run a query on the smart meter, so we are using spark.sql, and we are running the same query here, right? We are running the same query which we have run using SQL command. So see, the results should be same. Okay, so since this is data frame, we need to go for show as well here. So this is cool, and if we want to see the result, summary dot show, and run it, so it will show the results. Okay, so this is good, great, right? So we have done all the analysis. Now let's say we want to save this again into the table again. So there will be new table created after this, and the table name will be your device summary. Right, so this is great. Now let's say if we want to run a SQL. So once we press %SQL, the cell will be changed to SQL, and now we can run a plain query. Select star from device summary. Run cell this, and we will sing the same command. So it means we have copied the same command. And the one more cool thing about this one, right? So if we want to see the results into your visualization, so what we can see, we can go for, let's say, bar chart, and we can see clearly how the results look like, right? So let's save it, and we can clearly see results here. So this is super handy to see the visualization, right? So this is how you connected your Databricks to the container, do some processing, do some analysis, and now let's see till what we have covered so far. So now we have covered this as well, right? Now the last thing what we will be doing, we want to have the real-time alerts. We want to have real-time alerts. So now for real-time alerts, we will be doing multiple things. So we know that we have our Stream Analytics job running, which is consuming data from IoT, and we want to send results. Anomaly detection, we need to do the anomaly detection. It means anomaly detection means what? If temperature goes beyond certain point, if this is anomaly, it means if temperature is like in the range this 35, and if it suddenly goes to 60, it means this particular point is the anomaly, right? If we want to detect it, and we need to send this anomaly to Gmail, to my Gmail account. So to do this, what we will be doing, we will be using the same thing, and we will be using anomaly detection feature of Stream Analytics. So in Stream Analytics, we have a feature of anomaly detection. We will be using it, and I'll show it to you. But to do this, to send an alert to Gmail, we will be using Logic App here, right? We will be calling this Logic App through a function, right? Azure function. Inside this Azure function, we will be, okay, before Azure function, we will be sending this Stream Analytics jobs to Event Hub, right? This once this data comes to Event Hub, we will be calling the Azure function. This Azure function will call the Logic App, and this Logic App will send the Gmail, right? So seems complicated, I know, but don't worry, we will be making it very simple, right? So okay, so now since we have done our Databricks computation, what I would prefer, stop it. We don't want to waste our money, so just stop it. Next thing, what we will be doing, go to your resource group and do here Event Hub, right? And I'll go for Event Hub, and let's say if I want to create a new Event Hub, I'll be creating an MSDN. I'll be creating into your this portal. What's the Event Hub name? Let's say my IoT smart meters. Okay, smart meters dot service bus. This is my namespace. I want to create this in your North Europe, and pricing tier should be standard, and throughput unit is okay. One advanced. Do we need to go for version? Networking is okay. Tags, I think it's okay. Review and create, and validation. We have created an event hub. So once we have created an event hub, so once this is created, we need to create a container inside it, right? So let's wait for it. Okay, so event hub, smart mentor. Okay, so spelling is wrong, but yeah, let it be. Event hub, let's go here, and let's create. So that was event hub namespace. Inside this event hub, let's say we create a container. The container we can create any name. Let's say anomaly. What we need to name it? Um, let's say anomaly detector. We can name it anything, right? Let's go for next captures. Okay, review and create, and then create it. So now event hub namespace is created, event hub is created, and now let's search here stream analytics, stream analytics job. So we have two jobs which are running. That's great. And we will create a new job, and we will call this as, let's say, eHub, right? And where do we running it? Everything is running on North Europe, so we will be running in North Europe, and we want to have one. We don't want to waste money, and we'll create it. So it will not take much time. Let's wait for it, and go to resource. In this input, so basically what is the input? IoT Hub only. Let's say smart meter, right? And save it, right? And output, what is the output? Output should be your eHub, right? Output should be your event hub. So since we have created in the same subscription, it picked it up automatically. Let's call it eHub, and everything should be same. That's great. Now go for query. So what it is doing, selecting star, selecting everything from IoT and sending data to your event hub. So data is coming, that's great. And now we will be using, okay, so first thing first, why we are doing it? We are doing it to predict the anomaly detection, right? So now there is, I have created a query here. I'll copy paste it. And I'll explain it to you, don't worry. Okay, so basically not from here but from smart meter, and that's great. Okay, so what I have done so far, let me explain it to you now. What we are doing, we are creating a CT, right, a temporary table, and inside this temporary table what I'm doing, I'm selecting the system timestamp, I'm casting the temperature to float, We are selecting everything from your IoT hub, right? And then we are using the tumbling window here. And tumbling window, let's say we want to detect the anomaly every 30 seconds, right? So this is great. And now one more CT we are creating called anomaly detection step. So what we are doing here, now this is interesting. So see, this anomaly detection, a spike and dip, is a built-in feature of your stream analytics. So what it will do, it will see the data. It will see the data in these ranges, and it will use spike and dip algorithm. And if the anomaly is detected, it will trigger, or it will generate the output. Okay, we'll see. And at the end, what we are doing, oh yeah, so we are using from anomaly detection step, we are selecting a score, like what's the score of the anomaly, and then we are seeing whether it is anomaly or not every 30 seconds, right? And then we are selecting ID, time, temperature, everything. So let's see, let's test the query. If it works, then we are good, but it's not working. So let me see, anomaly where is equal to 0. Let me test again. Okay, so it means we didn't find any anomaly yet. So I just put the 0 here just to show you whether our results are coming or not. So we will be generating the anomaly in some time, but for a time being, let's put it 1 and save this query. Okay, so it means in fact, let me do one thing. Let me put 0 so that at least we can test the data, right? So 0 means the anomaly is not there, but let's see, because we want to test further and we want to see the data. Once we do it in production, we will put as 1. Okay, so what we are seeing here, that our anomaly detection step is working fine, and once we save this query, we are going to overview, we are going to start this query. Okay, refresh it first, start it now, and start now. So what it will do, it will send this particular stream analytics job, will calculate the anomaly and send it to Event Hub, right? So let's go home, and okay, and I'm going to my Event Hub. So let's go for IoT project, and where is our Event Hub? So we just created the Event Hub, right? Oh, this one is Smart Mentor. Okay, and fantastic. So data started coming now, see? And now, so it means the data started flowing into our Event Hub, right? So this is great. So we need to capture these events. How will we will be doing it? We will be doing this using using our one of the Azure function. So this is the last section of this project. So basically, as I in the beginning, we were discussing that okay, we will be sending an email if there is an issue or there is an anomaly, right? So basically, what we have done so far, we have our IoT hub, right? This IoT hub is sending data to our stream analytics job, and from stream analytics job, what we want to do, we want to find the anomaly, and if anomaly occurs, we need to send this data to Event Hub, and from this Event Hub we will be writing a function, Azure function, and this function will send data to a Logic app, and this Logic app will send an email to us. So this is we are going to do. So see, this is just one way to alert to your mailbox. There can be another easy ways, but this is the most easy and cost efficient way which I know. Okay, now the question arises, why we cannot have stream analytics sent to function? So I think there is no functionality as such, so that's why we need to go through this path. Okay, so first thing what we need to do, we need to create a event hub, right? So let's go to Azure portal, and what I have done, I have created an event hub already. So that's called ehub test. Inside this, sorry, not this one. So let's go here. I have created an event hub called Smart Mentor, and inside this event hub namespace, we have created an event hub called anomaly detector. Simple. We haven't done anything. Okay. So now the next thing what we want to do is to write a stream analytics job, right? And inside that stream analytics job, what we need to do, sorry, not this one. Inside that stream analytics job, we need to do some anomaly detection, right? So what I have done, I have already created a stream analytics job called ehub, and once we see this job, we already have an input from the smart meter, that is your IoT hub. In the output, what I have done, I have put a name as ehub, and it is pointing to the same anomaly detector event hub. Let's see. One most important thing which we need to take care, and which should be we should be careful, is the output format should be JSON, and the format should be line separated. Simple, right? So now when we go here and we see the query, so the query looks like something like this. So let's minimize all this stuff, this as well. And once we see this query, so what we are doing here, we are using anomaly detection of stream analytics. So I haven't written this code. This code is readily available on Microsoft Learn, right? So this particular functionality is called anomaly detection spike and dip. What this does, detects temporary anomalies in the time series event. So our events are time series because when we see here, it is generating time stamp every second and the temperature of the devices. So it means this is our time series data. So when there is any anomaly, whether there's a spike or dip, it will use the machine learning model using adaptive kernel density estimation algorithm. I won't be deep diving into it, but yeah, I will share this link and you guys can read it, right? So there are certain parameters which this anomaly detection takes: confidence, history size, mode, and different partition by clause, when clause, and different stuff. It's very easy, right? So what I have done, I have copied this and I have pasted it here. Same thing. I just changed few things according to my query. For example, I have changed it to system.timestamp, and I have used temperature here, right? Because we need to measure the anomaly in temperature. I have changed the tumbling window to 30, and I have selected, spike and dip here. And at the end, see, just for testing purpose, I'm putting it as 0, because when you see here, this is pretty streamlined data. There is no anomaly in it. We will be generating the anomaly for a time being. We kept it 0 so that we can see data here. So this should not be in production. In production, it will be 1. Okay, and I will do it at the end of the day. So I'll just save it. So it means the query is running, and when we go here, and not here, sorry, Stream Analytics Jobs, eHub, and Overview, and we will start this now. Okay, so that's stopped and we will be starting it. So it means it will pick up the data, it will do the anomaly detection, and it will send the data to our IoT hub. Oh, sorry, Event Hub, right? So I'll start it. It will take maybe a minute or so, and let it be done. Meanwhile, what we need to do, we need to create a Azure function, right? So let's go here and let's say Azure, or in fact write function app. So we have already created a function app, right? The consumption, when we go here, let's see if that can be seen. So we have already created a function app, and now what we need to do, we need to create a function inside this function app. The one thing what we need to take care while creating the function app, please choose the plan as consumption, because the other enterprise level plan might be very expensive, right? Now when we go for functions, there's one function is created here. Let's do one thing. Let me create another function for you guys. Let me disable this for a time being. So this is normal function app, Azure function app. Inside this function, what we want to read data from Event Hub. So when we write here event, right, and it will give us the result. Okay, event, give me a second, go to create again. Actually it's not getting refreshed anyways. Let's see. Yeah, so now it's working. So Event Hub, and select this, go to create. So what it will do, it will create Azure function for you guys. So I have already created one, but it created a new function called Event Hub trigger 2, right? Now when we go to the code and test, see, this is already done for us, right? So we have already, like, Azure function has already written to us. Next thing what we need to do, we just need to write our logic. But before we go to the logic, we need to make sure that this particular Event Hub, Azure function is reading data from the Event Hub. Let's go to integration and let's see what this function is exactly doing. So it is reading from Event Hub, running this function, but let's see from where it is reading data, right? So it is reading data from here. What we need to do, let's change the name to our anomaly detector. Let's go here, everything is good, and save it. It will take maybe a second or so. So it's updated. Now go to test. It is oh yeah, so our what we are seeing here, that your Stream Analytics job is running. So that's first step. Now when we go to Event Hub, I want to see whether data is flowing into Event Hub, right? So before the we are going to the function app, let's first validate whether the events are getting generated into your Event Hub, right, from your Stream Analytics. Okay, so let's do one thing. Okay, so still the events are not coming. So these are my past events. So the events are not coming right now. It might take a minute or so. So let's wait for it. And oh yeah, so we can see that, okay, it started generating again, that the job is popping. So Event Hub has generated data, and what we are seeing here, that your in your Event Hub trigger, we are seeing the data flowing in from your Event Hub, right? So this is good. So it means the data is coming in now, and we are good to go. So whenever there is any anomaly detected into your Stream Analytics job, it will send that anomaly to your Event Hub. From the Event Hub, we are reading the data using your Event Hub trigger one Azure function. So it means we are good here, right? And so when let's stop it. Let's stop the query and refresh it again, just to see that data is coming in again and again, right? And so let's refresh the query. Once the job is stopped, we will be pasting this anomaly detection query again, because right now what I did, just to make sure that the data is coming, I just pasted a simple query just to have the connection testing. And now we're going to be changing this select star from into IOT Hub query with the anomaly detection query using your spike and dip method. Okay, so this job has been stopped. We cannot change the query till the time job has not been stopped, right? So once the job is stopped, now job is stopped, and we will be copy pasting that query. We're gonna be changing the input from your IoT input to smart meter, right? So once it is done, we will be testing it, and if this query is giving result, then we are good to go. So it will take maybe a second. So the result is not coming because there is no anomaly detected right now. We might need to change the simulator to generate the anomaly. So what we are doing here, so see the temperature is in the range of 37 to 40, so there is no anomaly. So we might need to do, we can do two things. Either we can tweak the query, or we can tweak the simulator. So I will be showing you both. Okay, so I'm starting, I have tweaked the query right now. Just to what I have done, I have changed the confidence interval for the query, and it worked. Okay, so now what we can see, the data is coming into your Event Hub trigger function app, and yeah, so when we see the data is coming in here now, we will be creating a logic app. And what this logic app will do, our Event Hub function app will send the data to this logic app. So we will be creating this logic app into our MSDN subscription and into your resource group, and let's say we call this logic app as send Gmail IoT. Okay, we will be creating this logic app into North Europe region, and because every other resources are North Europe, right? And we will be putting that logic app into consumption plan, because consumption plan is cheap and it's good for testing. And we will directly say review and create. So once this logic app is created, we will go to your logic app designer, and we will get the logic app URL. Okay, so this is done. Let's go to the resource, and yeah, so let's go to your logic app designer. So we will be using HTTP request once HTTP request is received, because the trigger from Azure function is a HTTP request, right? And we will be saving this to generate the URL. So it won't show us the URL till the time we won't save it. So let's go for the save option. And so once we save it, we will be seeing the URL. So this is great. So we will be using this URL into your Azure function. Right now this Azure function is just pulling data from your Event Hub and popping this onto the console. Now we need to change 4 or 5 things to make this thing work, the connection between Event Hub function and your and logic app. So these are the, we need to do few imports. We need to create a variable for the logic app URI, right? So we have imported your tasks, threading task, and we have imported HTTP, and we have created a private variable called logic app URI, and we're gonna be updating this logic app URI with our URL of the logic app, right? So this is the first initial step. The second thing is using that URI to send message to logic app. So let's copy paste one more line. So we are creating a variable called response, and in this variable we are using Logic App URI, and we will be sending this message body to our Logic App using that response variable. Okay, so we are using post async method, and the Logic App URI address and message body will be sent in UTF-8 format into application JSON. So we will be saving it, and now we will be validating whether this code is working. One thing what I did, as I was discussing with you guys, that I will do two things. I will change the function, as well as I have changed the simulator. So I have changed the temperature to 100, and that's why the color is red there, right? So this is working now. So now we need to use this payload into your Logic app. So we have copied this payload to generate the schema. So we will be using this sample payload to generate schema method here, right? So once we paste it here and say done, our schema is automatically generated. So this is the schema for your anomaly message from Event Hub. Next thing what we will be doing, we need to use Gmail method here, action here, to send Gmail to us, right? So we will be going, since I have already done it, just to show you guys, I'll go for send email, I'll go for change connection. Why I'm using change connection, you might not see this option for the first time because I have already done it, and I'll go for add new just to show you guys. Let's put a name there, let's say test 1 or test 2, right? And go for sign in. Once you go for sign in, you need to allow this Logic app access to your Gmail account. So once this is done, we need to add two more things. One is your subject and body. So this is done. So means your connection is established, right? So now let's add subject and body. And once this subject and body has been added, let's do dynamic content. So in the dynamic content, when you put ID, so it means the schema what you have generated, this schema can be used here. So ID, and let's say we need to use temperature. So this is your body, right? So, and in the subject we will be saying ID and time. So these content are coming from the schema what we have generated using payload. Okay, we will be saving it, and we will see whether this Logic app will be able to send data email to our Gmail account. So let's wait for it. Oh yeah, one more thing is, where do we need to send? So let's say I'm using my Gmail account, your Hadoop tutor at gmail.com, and save it, you know. So it has been saved successfully. And now next thing is, okay, so first of all, again, validate whether data is still coming. Yes, data is coming, anomalies are still coming. Now go to your Gmail just to see your just refresh it. Yeah, so what we are seeing here, that once the anomaly has been raised, and oh, so let's give some space so that it's more readable, you know. Because it is not readable. ID and device ID and temperature and time are stuck together, so there's no space in them. So let's refresh it again, and perfect. So what we are seeing, that okay, there is an anomaly since the device 1 is generating temperature of 101 degrees Celsius. The ideal temperature is around 37-38, but it has been heating up, and this is anomaly. So we got an email, successful. So we have successfully created a alert using your spike and dip anomaly detector algorithm from your Stream Analytics. We have populated it using your Event Hub from your Azure function. We have sent an alert. So everything is done, right? So let's see. Okay, so now see, now the data is still coming. Now what we need to do, we need to stop everything else, our Gmail will be full. So we need to stop our Event Hub job. We need to stop our simulator, right? And stop everything. So this is the best practice. Once you're done, to stop the cost, to stop the space and storage, just stop everything. So these are few of the best practices what you guys need to follow. And now let's revise what we have done so far in this project. The first step what we have done, we have created a simulator in a VM, right, using your C has language. In this simulator we are producing two things, temperature and voltage, although we have only used temperature, but we can use voltage also for any analysis. Then we have created your IoT hub, and one more thing what we've created is IoT hub plus DSP. DPS means your device provisioning service. In device provisioning service we have created your group enrollment key and your scope, and these two variables or these two information we have used into your simulator for the connection between the simulator and the IoT hub. So when you are registering a device in the simulator using register button, it will use these two GEK and scope to register itself with the IoT hub. Now what we have done, we have created a stream analytics job, and in any stream analytics job we need three things: input, query and output. For almost all the jobs we have input as IoT in this project, because obviously the data is flowing in from simulator to IoT. And for the first output job, what we have done, it's a hot output. It means we need to have the real-time information onto the dashboard. So, and we are populating this information on the Power BI. So since the restriction with Power BI is we need to have the same user who is using stream analytics job and Power BI, we have created a new user in Azure Active Directory, and we have logged in using that user into your Power BI workspace. We have created a new workspace. We have used the same user to log into the Azure portal, and then we have created output, and that the workspace which was created is automatically populated here. And then we have created a table, data set, and then we have used a table and data set to produce a report into the Power BI. The second thing what we have done is we have created a storage account, and we have created a new stream analytics job, use input as IoT hub, and then we have populated this storage account with different folders like year, month, and then hour and everything. And then we have used this storage account with the Databricks to analyze this data. Third thing is complicated. So what we have done, we need to do the alerting for the anomaly detection. So what we have done, we have created an event hub, populated that event hub with the stream analytics job. In the stream analytics job, we have used a spike and dip algorithm, right? We have written a query and we have populated the event hub. Now the next thing what we have done, we have created a Azure function, and that Azure function will be triggered whenever any event is coming into that event hub, right? And so what we have done, once the events flowing into the Azure function, we can see, we have seen and validated using certain methods that okay, on the console we have the method, we have the messages coming in. Next thing what we have done, we have created a logic app, and we have integrated the logic app with your Azure function using 4 or 5 variables, and then we have validated Gmail is done. So this is what we have done so far. We have done your simulation, we have done your IoT, Power BI, Databricks, alerting, lot of things, right? I know this is very complicated project. It took me 2 or 3 days to complete this project. So many debugging, repetition I have done. So don't worry if you guys are not able to complete it in a go. Keep practicing. If you guys struggle somewhere, let me know. Put the question into comment, email me, message me on LinkedIn. I'm more than happy to help you guys. Again, thanks for all the help and support. Please do share this video. Please subscribe to my channel and like the video. Thanks a lot.